Well, let's say we've been given a complex number z1, which is equal to, let's say, 2 cos 90 degrees plus I sin 90 degrees, and then we've been given z2, which is equal to, let's say, 3 cos pi over 6 plus I sin pi over 6. Now we want to perform the operation z1 minus z2. How do we get to subtract these two complex numbers? So what we are going to do is, first we are going to express this one in rectangular form. The x components, we add them together now with the x components of the other one. Okay, so this will be 2. Okay, cos 90 degrees is a 0, and then plus sin 90 degrees is a 1. So this will be 1 times I, which is an I. And then this side, pi over 6 is a 30. So if you have 60 degrees there, this is 30 degrees. This is a 90-degree triangle, and we are using special angles in this way. So cos 30, cos is the adjacent over hypotenuse, so that is root 3 over 2. And then you have got plus, you have got I. Now sin 30 is 1 over 2. Okay, like that. Now let's go on. If we go on and simplify this will just give us a 2I, because 2 times 0 is a 0 anyway. Now this one, let's go on and multiply. This is going to give us 3 root 3 over 2 plus 3 times half, that will give us 3 over 2. Can put an I there. Now to perform the operation z1 minus z2, we'll get the real part for z1. Now you can see the real part we don't have. The real part is 0, in other words. That will be 0. We subtract the real part of z2 because we're saying z1 minus z2, so that will be minus 3 root 3 over 2. And then plus, what we are going to do is we are going to get the imaginary part for this one. Okay, the imaginary part for the first one. We subtract the imaginary part for the second one, which is 3 over 2. Then we are going to put an I at that point. The way we can also write this is saying 2I minus, now we are subtracting 3 over 2 root 3 plus 3 over 2I. So this is what we are subtracting, and so this is going to simplify it into 2I minus 3 over 2 root 3, and then another minus, because this minus is distributed to everything there, minus 3 over 2I. Now at this point we're going to put those which have imaginary parts together and those which have got real parts together. You can see that the only thing with a real part is this one, that is negative 3 over 2 root 3, and then you've got positive 2I. Now I can write it as 2 and then minus 3 over 2. We can write now the I outside because both of them have got I's. You can also take it like that. Well, so this is going to give us negative 3 root 3 over 2 plus, that should give us 1 over 2I. If we subtract 2 minus 3 halves, okay, so that is 2 minus 3 over 2, which is a half. Now at this point we want to leave our answer in polar form. So what you do is we are going to convert this complex number that we have found in polar form. And how do we do that? By finding the value for r and finding the value for theta. So r is given by you get the negative 3 root 3 over 2, square it, and then so we've gotten this portion. We also get this portion, we also square it, so that is 1 over 2 squared, and then we're going to square root that, so that is going to give us 3 squared is a 9, 9 times 3 is 18, 18 over 2 is a 9, and then plus what you have there is 1 over 4, and then we are taking the square root of that, so 9 plus 1 over 4, and then we square root that. So what you should be able to find is approximately 3.04 as a value. Now to find the angle theta, theta is going to be equal to tan inverse of y over x. Y is the portion which has got a I, so that is 1 over 2, and then divided by x is the portion that doesn't have any I, that is the negative 3 root 3 over 2. Okay, so this is going to give us tan inverse of, if we take this on top, the negative 3 over 2 is going to come down, and so on top we are going to have to remain as negative 1 over 3 root 3. That is because if this one goes on top, it is going to cancel out with this one. Okay, so we can simply go on and punch that on the calculator. Of course, we have got negative 1 divided by 3 root 3, tan inverse of that, that is about negative 10.89 degrees. Now if we consider in which quadrant this angle is, what we can see is x is negative and then y is positive, so it is going to be in this quadrant, and the angle that you found theta is this one. So I want to find the positive angle, so to this one we are going to add 180 degrees, and that gives us 169.1 degrees as the angle theta. We can go on now and express it in the form that is wanted. Then we're going to say z1 minus z2 is equal to r. R we found 3.04, open brackets, cos the angle theta is 169 degrees. Let me just write it as a whole number, plus I sine 169 degrees. So that is going to be the answer then after performing the subtraction.